This is our first lecture, and this is on Chapter R, Prerequisites. Everything in Chapter R should be a review, I will therefore present a couple of problems from each section. Of course, if you have any questions, I would like you to email me or call me. So Chapter R, the title is Functions, Graphs, and Models. We're going to look at sections R.1 through R.5. R.1 is all about graphs and equations. I'm only going to look at one problem here, which is problem 29 on page 11. If you look at the problem, it's entitled Compound Interest. An investor purchases a 100,000 certificate of deposit from Newton Bank. So that's the principal, 100,000. At 2.8%, that's the rate per year, the annual interest rate. How much is the investment worth, rounded to the nearest cent, at the end of 1 year? So time, t equals 1 year. And if the interest is compounded, part A, n, annually, which means once per year. Part B, semi-annually, which means twice a year. Part C, quarterly. There are 4 quarters in a year. Part D, daily, where n is 365 days. And finally, hourly. That's E, and equals 24 hours a day multiplied by 365. I'm multiplying these two. 24 multiplied by 365. I get 8760. 8760. 8,760 hours. At this point, what I'm going to do is I am going to look at grab my graphing calculator and press y equals, where I will put in a function. Here's our function. The accumulated interest, the accumulated value, of course it includes interest, it's called A, or denoted by A, equals the principal, what we deposit, 1 plus R, which is the interest, the annual interest rate, divided by the number of times we compound the interest. Everything raised to the number of times we compound interest multiplied by t, which is the number of years, in this case t equals 1. The function that I will create in the graphing calculator will be a function, let's say f of x or y, which will be 100,000 multiplied by 1 plus 0.028, which is the interest in decimal form, divided by x, because x is the value that changes. The reason I put x is because there is no n in the graphing calculator. Everything raised to x times 1. So 100,000 multiplied by 1 plus 0.028 divided by x. Everything raised to power x. I prefer putting x in parentheses. It's not really necessary. You can keep it without. But if there is an operation at power, then you will need parentheses. I go to second and table set and make sure that the independent variable is in the ask mode. And it is. I used this calculator before. So now I go to second and table. And I will put in the numbers that I was given initially. So I will put in 1, enter, 2, enter, 4, enter, 365, enter, and 8,760, and enter. Now I go to the right and copy all my answers. So I will say f of x for f equals 1. I get 102,800. F of 2, I got 102,819.60. F of 4 is 102,829.55. F of 365, and finally F of 8,760. So F of 365 is 102,839.46. And finally, 102,839.56. That's really all I wanted to show you from R1. I am moving on to R2. That's my page 2. And R.2 is functions and models. I kindly recommend please read the entire section with the examples as I mentioned in the syllabus. And I'm going to present a couple of problems here. One problem is problem 23 on page 22. And we are given a function which is f of x. It's a rational function, 1 over x plus 3 to the second power. And we are asked to determine several values, among which, so in part A, we're asked to find f of 4. Then we're asked to find f of negative 3, f of 0, f of a, f of t plus 4, and finally f of x plus h. After all this, we're asked to simplify what is called the difference quotient, which is, I will shorten dq. I will abbreviate it as dq, and that is f of x plus h minus f of x divided by h. So coming back to f of 4, nothing special here. 4 plus 3 is 7. 7 squared is 49, 1 over 49. Negative 3 plus 3 is 0, and the denominator is 0. Therefore, the function is undefined. A number divided by 0 does not exist. We like to write or say the expression is undefined at that point. F of 0, 0 plus 3 is 3. 3 squared is 9, so 1 over 9. F of a, remember how to read a function. This particular function really tells us this. F of whatever you want, except negative 3, is 1 over whatever plus 3, everything squared. So I have f of a. All I have to do is replace put a in the box. So I have 1 over a plus 3, everything squared. The same thing with f of t plus 4, which will be 1 over t plus 4 plus 3, everything squared, which is 1 over t plus 7 squared. Nothing else is required here. Obviously, the same thing with f of x plus h. So it's 1 over x plus h plus 3, everything squared. Now, this is the most important part of this section, where we calculate and simplify the difference quotient. F of x plus h was just determined right here. This is the f of x plus h minus f of x. All I have to do is replace f of x plus h by this expression and then copy f of x. So 1 divided by x plus h plus 3, everything squared, minus 1 over x plus 3, everything squared. At this point, I have to find the least common denominator in the numerator. Well, these two factors have nothing in common. Therefore, it must be the product of the two. The least common denominator is the product of these two. Therefore, the numerator of the first fraction has to get an x plus 3 squared, and the numerator of the second fraction has to get what it does not have. The least common denominator is x plus 3 squared times x plus h plus 3 squared, and the denominator here does not have x plus h. It was multiplied by it. So then we have to do the same thing to the numerator. So therefore, the numerator of this expression will be x plus 3 everything squared minus x plus h plus 3 everything squared. Instead of squaring these quantities, the binomial and the trinomial, I will be using, to simplify, I will be using the formula a squared minus b squared, which is the difference of squares, which factors into a plus b times a minus b. So this will be my a plus b, forgive me, my a, and this will be my b. All I have to do now is just fill in the gaps in here. So I will be moving on to page 3. So here's my continued expression. So, and this is h over 1. Then x plus 3 plus x plus h plus 3. And I finished with this part, multiplied by, this time x plus 3, but minus this quantity. And I have to distribute a negative sign to all three terms. Minus x, minus h, minus 3. Over x plus 3 squared, which will never expand, as well as x plus h plus 3 squared. And I'm multiplying by the multiplicative inverse of this. There are two fractions divided. I copy the top and I flip the denominator. Now, I will try to simplify as much as possible in the numerator. And here it is, negative x with positive x, negative 3 with positive 3, and there is a negative h that will go in front of the parentheses. So negative h. And now x plus x is 2x plus h and plus 6. Everything divided by x plus 3 squared, x plus h plus 3 squared, multiplied by 1 over h. Therefore, final step, I'll simplify a factor from the top with a factor from the bottom. They are the same. I will keep the negative sign in front, and I have 2x plus h plus 6 over x plus 3 squared, x plus h plus 3 squared. Now, the other problem that I wanted to look at in section R.2 is graphing a piecewise defined function. Oh, part B of, I completely forgot about part B of this problem, problem 23. It says, note that if f could also be given by, explain what this does to an input number x. Okay, so part B, they are just telling us that, which indeed is true, 1 plus x plus 3 squared is indeed the same thing with, I'm using the formula a plus b everything squared, which is a squared plus 2ab and plus b squared. Obviously, if the binomial has a difference, then the trinomial will have a minus on the second term. Therefore, x is a, b is 3. Then we have x squared plus 2 times x times 3, 2 times x times 3, which is 6x, plus 3 squared, which is 9. Yes, this is the same thing that I mentioned before. This is what the function is asking us to do. So for whatever except -3, so whatever you want to evaluate the function for, all you have to do is plug it in those 3 boxes. The other problem that I wanted to show is how to graph a piecewise defined function. And I chose problem 61 on page 23. We are given a function that is defined in pieces. Actually, it has 3 pieces. The first piece is 1/2 minus 1, only when x is less than 2. The second piece is -4, only when x is 2. And the third piece is x minus 3, only for x greater than 2. Every time I'm asked to graph a function, I have to start by identifying or determining or stating its domain. I see that this function is defined on all real numbers because it's defined to the left of 2, is defined at 2, and it's defined to the right of 2. So this is, well, in this row, I will present the domain of this function, which is indeed -infinity to infinity. Then I realize that this number, which is 2, has a tremendous importance. It has to be put in the chart, in the table. To the left-hand side, this portion of the domain can be rewritten like this. And this portion of the domain can be rewritten like this. I am going to use these 2 symbols accordingly. Right under 2, to the left-hand side of parenthesis, to the right-hand side of parenthesis, and I know that when x is 2, the function value is -4. So -4 will go right in here. On this portion of the real line, I will be using 1/2 x minus 1. On this portion of the real line, I will be using x minus 3. And now, since both functions are linear functions, I do not need more than 2 points on either side. So when x is 0, 1/2 times 0 is 0. 0 minus 1 is -1. When x is 2, 1/2 times 2 is 1. 1 minus 1 is 0. In case you're wondering why I plugged in 2, I will explain that in a minute. Yes, I'm not allowed to, but I have to. So on the other side, I plug in 2. 2 minus 3 is -1. And of course, the other number should be 3 because I'm always looking for the x and y intercepts. 3 minus 3 is 0. That's all I need in the chart. And now I'm going to go to page 4, use my chart, and graph this piecewise defined function. So I am on page 4. And I want to graph the function. The first point that I start with is the point 0, -1. So I put that point in the chart that I have in the chart. I put it in the Cartesian system. So 0, -1 is this point. The next point that I have to put in the chart will be 2, 0. However, this point is not a full point. If this were a bracket in here, then this would have been a full point. However, this is an open point. And the left-hand side has this graph. I'm not allowed to extend this graph to the right. This is the function that is defined on -infinity to 2. It cannot be extended anywhere else. Now I have to plot the point 2, -4. 1, 2, 3, 4, which is a full point. On the other side, 2, -1 is my first point. It's also an open point. This will not be a function if it had more than one full point at x equals 2. And at 3 equals 0. 1, 2, 3. That's a full point. Here's the graph of function g of x. Okay. Now, finding domain and range, that is section R.3. So, in R.3, finding, domain and range. And I would like to look at a couple of problems here as well, like problem 27 on page 31. And I will be reading from the graph from the book, not from my graph, which kind of looks like this. In order to determine, we're asked to find its domain, f of 1. So here are the questions. Let me write them down first. So f of 1, part B. Part B, where are you, part B? The domain. Part C, all x values such f of x equals 2. So find x. And in part D, the range. Very good. So we start with f of 1. Of course, one more time, we read from the graph in the book, not from my graph. In order to find f of 1, x is given as being 1. I have to draw a vertical line, which is x equals 1. I see that it crosses the graph of the function at a particular point, and I will be reading the y value. And I do that in the book, and I see that x equals, when x equals 1, y equals -2. So I will say that f of 1 equals -2. I can also give the ordered pair, 1, -2. In part B, I am asked to find the domain. The domain is read on the x-axis from the leftmost full point, from the leftmost point to the rightmost point. If these are open, or if one of them are open points, then I will be using a parenthesis. So the domain in this case is from the book between -4 and +2. -4 and +2. Now I'm asked to determine x when f of x is 2. F of x equals 2 represents y equals 2. So I will be drawing a horizontal line this time. Y equals 2. It crosses the graph of the function in one point. And I will be reading the x value. So when y is 2, x is -2 from the graph of the function. So that implies f of x equals 2 implies x equals -2. I can write it as an ordered pair format, x, y. Finally, I am asked to find the range. The range is determined from the lowest y value till the largest y value, and it's measured on the y-axis, from the smallest possible y till the largest possible y. From the graph, I see it's between -3 and 3. So the range of this function is between -3 and 3. I will also would like to look at problem 31 on the same page 31. Huh. So problem on page 5. So we are looking at problem 31 on page 31. And that graph is actually a piecewise defined function. And here is its graph. Again, we will be reading from the graph in the book. So again, we're asked to find f of 1. So f of 1. I draw a horizontal line. I draw a vertical line at x equals 1, forgive me. When x equals 1, here it is. This is x equals 1. It crosses the function at the full point, not at the open point. And I read the y value to be 1. So f of 1 is 1. In part B, we're asked to find the domain. The domain of this function is anywhere between -5 and +5. This is -5, this is +5, and this will be a full point, this will be an open point. This will be the domain between -5 and 5, not 5. Then we're asked to find all values of x such that f of x is 2. This time I will draw a horizontal line. So this is y equals 2, and I will determine the function, the x values for that. So this is the interval. And the interval is between 3 and 5. So 3 and 5. So I will write f of x is 2 when x is in the interval, or can be anything. I can also write it like this. For any value of x between 3, including 3, but not including 5, the function value will be 2. Finally, we're asked to find the range of this function. The range is measured on the y-axis, and now I have to read, and I will be reading one value here, 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 and nothing in between. When I cross with horizontal lines the function, I only can hit it here for this value of x, for this, this, and this, nothing in between. And those values from the book are -2, -1, 0, 1, and 2. Careful how we present it. -2, -1, 0, 1, and 2, because nothing in between is part of the function. I would like to look at problem 53, where we're asked to find the domain. 53 on page 32. And the function we're given is f of x equals 2x minus 6 divided by x squared minus 6x plus 5. We're asked to find the domain. Before we find the domain, we have to completely factor the denominator. And I can factor it into x minus 1 and x minus 5. I know that a number divided by 0 is undefined. When will the denominator be 0? X minus 1 times x minus 5 will be 0 if x is 1 or x is 5. Therefore, these are the values that have to be excluded from the domain. So therefore, the domain will be -∞ to 1, union 1 to 5, union 5 to infinity. In plain English, everything but 1 and 5, as I knew. The final problem that I wanted to look at here is problem 59 on page 32. And I'm on page 6. 59 on 32. Just the part, we know how to determine the domain of that function. When you look at the graph, it will be easy to determine that the domain. Look at the graph, please, in the book. It's between 0 and 84.7. And the range of that function, also no problem there, is between 0 and 4,600,000. Well, what I really wanted to look at is if you were marketing a new type of hearing aid, that's all about the hearing aids. At what age group expressed as a 10-year interval would you target advertisement? And of course, you see that the maximum of this function, which gives the number in millions of hearing impaired Americans, you see it's highest somewhere between the age group of 50 and 60. If you're marketing a new type of hearing aid, at what age group expressed? Because expressed as 10-year intervals, would you target advertisements? Where the function has a maximum, a peak. Okay, we're moving on to R.4. And this is slope and linear functions. And again, this is all a review for you. So I'm going directly to a couple of problems that I would like to look at. And the first one is problem 69 on 46. And it says profit and loss analysis. Jimmy decides to mow lawns to earn money. The initial cost of the lawnmower is $250, and gas and maintenance costs are $4 per lawn. Formulate a function c of x, that's our first question, part A, a function c of x, which is always fixed costs plus variable costs. The fixed cost obviously is $250, and the variable cost is $4 per lawn. So multiplied by the number of lawns he managed to get to per day, or overall. Jimmy determines, so our function that is c of x equals 4x plus 250. In part B, we're asked to, Jimmy determines that the total profit function for the lawn mowing business is given by, so he somehow determined the profit function, good for him, 9x minus 250. The final function for the total revenue from mowing X lawns, how much does he charge per lawn? Okay, find a function for the total revenue from mowing X lawns. Okay, so we know that the revenue minus the cost will always equal the profit. So we have the profit function, we have the cost function, so we want to find the revenue. So I will replace c of x by 4x plus 250, and I will replace p of x by 9x minus 250. So r of x is, or I can already move c of x to the other side. So it's 4x plus 250. and plus the profit function, which is 9x minus 250. So the revenue is 13x, which clearly means that he charges $13 per lawn. How many lawns must Jimmy mow before he begins making a profit? So in part C, we want the profit to be 0 for the break-even point. And from there moment on, we know what we should what should x be in order for us to make profit, or for Jimmy to make profit. So P of x equals 0 means 9x minus 250 equals 0, or 9x equals 250, or from here x equals 250 divided by 9, which gives us, when you divide 250 by 9, roughly, and we get 28, approximately 28. So he should charge, this is the number of lawns. He's charging 13. This is the number of lawns he should get to in order to break even. Obviously, we will advise him to work much harder than that if he wants to make profit. So he needs at least 28 lawns to make profit, to start making profit. Okay. That's pretty much all I wanted to present from R4. And the last section is nonlinear functions and models. So that's my last page, I think. So this is R5, nonlinear functions and models. And I wanted to look at a couple of problems, or yes, a couple, yeah, actually I think I was looking at just one problem. Problem 91 on page 67. And please read the section. The demand function is given Q equals x minus 3 squared, and the supply function is given as Q equals x squared plus 2x and plus 1. Assume that x is less than or equal to 3. Let's see what we are asked to determine. Find the equilibrium point for each pair of demand and supply functions. So the equilibrium point is when the demand equals the supply. So x minus 3 everything squared equals x squared plus 2x plus 1. This is a quadratic equation. I will square the left-hand side. Remember, a binomial squared is always a trinomial. And I was just, if you remember, talking about a minus b everything squared as being x squared minus 2ab and plus b squared. I have x squared minus 6x plus 9 set equal to x squared plus 2x plus 1. Obviously, I will subtract x squared from both sides, and then I will move 2x to one side and 9 to the left side and 9 to the right-hand side. When I move a term from one side to the other, what I have to do is subtract or change its sign. Negative 6x minus 2x is negative 8x. When I move positive 9 to the other side, I have to change its sign. 1 minus 9 is negative 8, so x equals 1. The equilibrium point is a point, so when x is 1, now I have to go back and plug in 1 in any of these equations. 1 plus 2 plus 1. That is 4. So price is $1 and the quantity in our example is 400. So at the price of $1 per unit, the number of units is 400. Thank you.